Hello and welcome to this video. My name is Jarno Baselier and welcome to this hacking quick tip where we will be talking about the web cache deception technique. And for the first time in the lifespan of my YouTube channel, this is the first hacking quick tip that I've created in English, because usually I create these videos in Dutch and now I've also created an English variant. So I was curious to see what it would do, since I've also created a few courses in English. You can check them out at Udemy or on my website. And I was curious to see if this would do anything, if you would like the fact that I'm doing these videos in English. If you do, let me know. Please give this video a great shout out, give it a like, and subscribe yourself to my channel if you haven't subscribed to it already. And if you like this, if I see that you like the fact that I'm creating English videos, then I think that I will create more of them in the future. Maybe I will create two versions of each video, a Dutch one and an English one, or maybe just only an English one. So I'm still thinking about a few different options and solutions. But for now, enjoy this video where we are going to explain the web cache deception technique. This is a very dangerous technique, and yes, you can protect yourself from it. I will come back to the protection part later in this video. But first, let's start by explaining what it is and show you a little demo about it. Thank you for watching and enjoy the video. Web cache deception, or WCD, is a lesser known but highly dangerous web security vulnerability that exploits misconfiguration in caching mechanisms to expose sensitive user data. WCD takes advantage of discrepancies between how web servers and caching systems interpreted URLs, tricking caches into storing private user-specific content as publicly accessible resources. This vulnerability is often overlooked by developers, yet it can lead to severe consequences, such as the leakage of personal information, session tokens, or even full account takeovers. So let's break down what the web cache deception really is, why path delimiters are critical to its exploitation, and how attackers exploit it. Web caching is the cornerstone of modern internet performance, designed to reduce server load and improve user experience by storing frequently accessed content closer to the user. When a client requests a resource such as a web page, an image, or a CSS file, the request often passes through a caching system such as a content delivery network, a CDN, like for instance Cloudflare, or a reverse proxy like Varnish, before it reaches the original server. If the cache contains a copy of the requested resource, we call this a cache hit, it serves it directly, avoiding the need to query the origin server. If the resource isn't cached, the request is forwarded to the origin server, which processes it and returns the response, often with caching instructions in its HTTP headers like cache control, vary, or h. And that's exactly what we see here in the image. We have the victim, which is just a user. We have a caching mechanism, and we have the origin server. The caching mechanism is closer to the user, so if something is already presented on the caching server, it is forwarded to the user immediately without reaching the origin server. Only if something is not available in the cache, the origin server is queried and the data is returned and stored to the cache, and when it's in the cache, everybody can access it, even an attacker or a malicious user. Caching systems are typically configured to store static content files like CSS, JavaScript, or JPEG because they don't need change based on the user. Dynamic content, such as a user's profile page like my profile or account or a dashboard, is user-specific and often contains sensitive data like names, email addresses, or authentication tokens. These pages are meant to be excluded from caching to prevent unauthorized access. However, the web cache deception attack exploits misconfigurations where dynamic content is mistakenly cached as if it were static, making it accessible to everyone who will request that specific cached URL. So the web cache deception is a vulnerability that occurs when an attacker manipulates a URL to trick a caching system into storing a dynamic user-specific page as a static resource. This happens due to a mismatch on how the origin server and the cache server interpreted the URL path. For example, an attacker might append a static file extension, like for instance //test.css, to a dynamic endpoint, like for instance my profile, so that it becomes my profile. Let's say that we have a website, so test.com, and there is a personal page called my account. Then the attacker might add something like test.css, and when it appends this test.css, the origin server will probably remove this, return the content of my account, but the caching mechanism will store it as test.css, and so the attacker can request this URL and get its personal data. In a web cache deception attack, the so-called path delimiters are important. Path delimiters, such as the // play a critical role in a web cache deception attack because they influence how URLs are parsed by both the origin server and the caching server. In a typical web cache deception attack, attackers use path delimiters to append a fake static file path to a dynamic endpoint, like we seen right here. Path delimiters are crucial because they enable attackers to create URLs that exploit discrepancies in path handling. It's important to note that we have to find a path delimiter that is understood by the caching server but is being ignored by the origin server. So the first thing an attacker needs to do with this attack is to find a vulnerable endpoint. The attacker starts by finding a dynamic page that contains sensitive user-specific data, and this page might display personal details, and this is a page we might want to target. So for this we are going to run a demo. This is the Portswigger demo. For this I have to log in first. And if all went well, we can log in into this demo. We don't have any subscriptions, that is just fine. Let's go back to web cache deception. So let's go to the right page and we will play web cache deception exploiting path delimiters. I already solved this, but that doesn't matter. Let's see, burp is running. Let's remove everything that's in here because we don't need it anymore. Let's remove all of the history as well. And now we can log in into the lab. Everything is running through Burp Suite, so we should see at least some things in the history, but it takes a while. And there we are. Let's simply log in with Wiener and Peter. And what we notice right here is that my API key is being displayed on the My Account page. And this is some vulnerable information on a personal page that should be dynamic and should never be cached. But as you will see, this page will be cached because another thing that's important, if we check out everything that happened, you can see that the My Account page is loaded by using a GET method. And that's important to know because post and put requests are usually not being cached, but GET methods are, so we can use and target this page. So this is the page the intruder will try to tingle with, and the next thing we need to do is to find a workable path delimiter. So this request, let's send it to the repeater, test it if we get a 200. So this is old, this is not the right one. Probably have some My Account somewhere else, like this one. Let's send it to the repeater, try it, it's 200, and now let's send it to the intruder. So we can check different path delimiters, and the place of the delimiter is right here. A delimiter, and behind it is test.jpg, for instance, and the delimiter will become our variable like this. And the next thing we will do is we will try different symbols as path delimiters. Let's start the attack, and as you will see, nothing of this will work and everything will result in a 404 status code because we don't need to URL encode these characters. They need to be interpreted, so not being URL encoded. And we have a 200 status code on the semicolon and we have a 200 status code on the question mark. So we have two path delimiters we can test if they work. Now let's first start with the semicolon and try test.jpg. It results in a 200 page, but we don't see any caching information in the response. So maybe with the semicolon we get no caching information as well, but we don't know which file types are being cached by the caching server. So let's check out everything here again to see some files that might get cached, and the thing that stands out is the JavaScript file. So let's change our JPEG to JavaScript like this. Let's see what it does with the question mark. It results in a 200 but no caching information. And let's try with the semicolon as well. And this is interesting, we get a X cache miss, so we do get some caching information, and the miss means that there is no cache available and the content is being retrieved by the origin server, and the second time we will get the cached content served. So if we send it again, we do get a X cache hit, and this is the cached content that is being served. So with this knowledge we can craft a payload. And let's get our unique URL, which is this. And we are going to send an email to our target user, which is Carlos. And in this email, we will add some JavaScript in the body. Let's change the unique part here. And we will send the normal page, which will retrieve the account page of Carlos. And we will append login.js. So it will be cached as login.js and we can retrieve this cached page if all went well, of course. So let's go to the exploit server and add it to the body of the mail and now deliver the exploit to the victim. And now let's visit this page to see if we get the page served by the caching mechanism, and we do. We get the page of Carlos, which is being cached, and we get its API key. So to submit the solution like this, we have solved the lab and we have exploited a web cache deception technique. So to prevent these kinds of attacks, make sure that any response containing user-specific data always sends the cache control no store private or the cache control no cache private header, and they look like this. No store, or at least use no cache like this. So the page will never be cached. Also make sure to validate URLs server side and reject file extensions in the URL that your web app simply doesn't use. I hope you enjoyed this video and find it valuable, and if you did, please consider supporting the channel by giving me a like. Even better, if you haven't subscribed yet, I'd love to have you join the community. Your subscription truly helps the channel grow, so please subscribe. Thank you for doing so, and you can also explore more of my content by visiting the links to my other channels in the description below, or support me in any way that feels right for you. Thank you so much for spending your time here with me. I hope you have a fantastic day filled with good luck and positive thoughts. And always remember that you are amazing. Thank you for watching and hope to see you in the next video. Let me know what you think of this English hacking quick tip. And for now, a great day. Bye bye and see you next time.